I I hate to say it, but people are idiots. I mean, not just one here, one there, one everywhere. So I just went for a nice bike ride. Sunny day. Everybody should be working because you know, Monday, and idiots everywhere. I mean, it's the only way to save humanity's dignity is probably to ensure we don't have too much time to. I I'm just I'm just I could, but I won't. No, no details. Sorry. Starting now, and let me get out of the way. Right. So, oh, nice. It's still running. So this is what we started like 4 hours ago, and I actually opened the activity monitor. And yeah, it's hovering between 200 and 250 megabytes. So the good thing is it's not leaking, right? It's not has not eaten up 4 gigabytes of memory. But what's a bit worrying is that it jumps between like 250, 55 and 200, which if I close this down, I mean, yes, the buffer here and this buffer here grows, and then at the end of the frame we clear it. So in theory it should be roughly the same size every frame, right? So what I imagine it's doing is the that this clear actually releases the memory and then reallocs here. Mm, would be nice if there was a clear but keep memory. You know what I mean? I really need to close some windows here, some tabs. I mean, talking about memory. So what I really want is, I mean, this has a, where's the clear? Oh, here. Where is the clear? There is no clear? Oh, here. I was in there. So here's a clear, right? This has no effect on the allocated capacity. So the capacity should stay huge, right? I want to do one check. We can get the capacity, right? We can get the capacity, right? Hmm. Returns the remaining spare capacity. I just want to know how much there is. Oh, it has a capacity method. I was just... So returns can hold without reallocating, right? So what I want to know is right here, print line capacity self. Almost, right? This will be a bit noisy, and I'm sorry about this. So in theory, you should see the same number twice, right? Why is memory fluctuating so much? I mean, a few megabytes per frame. So one is 124, 1024, the other is 128. And if I start adding, it keeps the previous capacity, right? So that's not the problem. That is interesting. Well, that's probably something for later. Let's have a quick look if we are on a clean project. Yes, we are. And I know what I want to do, but let's actually look into the to-do. So resource manager, I decided we put at the very, very bottom. Sorry. So we want to render a triangle with a texture, right? And I actually want to extend this with a quad. And we'll do this in some intermediate steps, right? So if I go into the data real quick, and this needs some sorting. Let's copy the default vertex shader to textured vertex shader. All of these shaders will need to be rewritten, and the fragment shader, right? Because textured fragment shader. Let's start with a textured vertex shader, right? So we will need a vec2, right? And that is texture chords, right? And these we just pass through. So we have out vec2 dash o dash chords, right? So we just say this is a hack anyway, but let's keep it there to not. So in the it's both vec2. So in the vertex shader, we just pass through whatever came in channel 1, right? Let me just check one thing real quick, because I want to use nope, I don't want to print this material metal. No, I just want to check in which order we pass through the vertex components, right? This is far too much overkill. Oh, actually, so the order is always position, texture, coordinate, color, right? Interesting, we don't have normals. Well, it's a 2D, so it's always position, texture, coordinate, color. That's just what I wanted to. We could look that up and bind that dynamically, or we could just have a fixed layout, right? And then in a textured fragment shader, actually what we would do here to do texture lookup, but for texture lookups we need uniform. So what I will use instead is in back to O dash chord. O is probably a bad name, but so we just use the texture coordinates as a color, right? So this is O dash chord dot x, and this is O dash chord dot y, right? So just to see that we're using that shader, right? And then we go to our effect IDs and say, okay, let's say we have a textured 3. This auto completion is so amazing, right? And then we go into a Fiiish app, and basically in the loading, this is pretty straightforward. I mean, that's why we created all the boilerplate, right? So you can do much more complicated stuff with the names, but I don't want to. And again, this will probably come from a config file in the near future, so I don't care too much about this. Oh, let's be a bit more diligent here. So this is textured vertex shader. And that's why we did all this boilerplate this morning to add a new shader. With one caveat, but to add a new shader or effect, we just do this, right? So now we have a have it registered. So if I do a cargo e-check, yeah, cargo check, and we have two problems. I can do a cargo run release, yes, sure. So let's actually put a quad in the upper left corner that uses that new shader, right? So at the very end, all our coordinates are normalized device coordinates right now, but that's intentional because we would need a uniform to do the projection matrix, and we don't have uniforms yet, but we're slowly getting there. So the position is upper left, right? Upper left. So let's say left. This would be the exact corner, and this would be the exact corner, but we want to leave some space, so let's make this 4. And then if we draw 1 by 1, we should have, let's do it 2 by 2. Let's make it bigger as the cursor, right? So this should use the new render effect to draw something in the, if I actually use the position here, to draw something in the upper left corner, right? Series, magnificent series. And, oh, yeah, obviously, -1 to, well, let's use 8, 8 here. It's -1 to 1. It's not 0.5 to -0.5 to 0.5. And as you see, that probably is using the new shader. I mean, we can just verify that by saying maybe this is very, very yellow, right? Let's check this. Oh. Warning, failed linking shaders into program. Maybe we should add the linking failed in vec2o techco. Oh, okay, it fails because this is optimized out now, right? So if we remove this, we remove this because the out is written, but it's not red, so the fragment shader is not using it, so it's the compile of this optimizes this out, and then the linker says, hey, you told me to write this, but so we just remove that. Let's see. Warning, failed linking shaders into program. It would be nice. So let's detour a bit, right? So improve shader problem debugging. Right, so we have the program. And one thing I want to do, actually, I could put this in this tuple, but shader sources. Because this is debugging feature, and to do make debug only, because, and this is basically a string, right? And then we say shade, actually let's put this at the bottom. Put this at the bottom, cause OCD and stuff. So step one, we remember the sources, right? So whenever we add a shader, basically here we say self.shader sources push source to string. So we remember this, right? And then when we have the failed linking, we say for s in self, we borrow here self.shader sources dot values, right? We just say print line s, right? So step one, dump the output. Remember the shader source, do a copy, which is expensive. Oops. Missing semicolon. No method found values. Oh. Iter key. And we actually don't use the key, we just use a string, right? Did I do something stupid? Fair enough. Oh, warming up again, right? So value moved here. Really? Really, really? I mean, we could just clone it here. Where's shader type defined? In renderer? It's in program. Program, shader type. Yes, let's make this copy and clone. I mean, this is an enum, right? Sorry. So we probably can get rid of the clone here because this is a copy now. Could make it a copy. Okay, so obviously, yeah, not now. Sorry. I've been calling my mom for 3 hours. Yeah, the debug now is getting a bit noisy, but I'm interested in this, right? Failed linking shaders into program. So both compiles work, the linking doesn't work. So why does the linking not work? Because this is saying tech chords and this is saying tech chord, right? So if I had written coordinates, oh, obviously then it's optimized out and actually the Why do we get a compile okay? So now it's yellowish, but we don't have the texture coordinates, right? In I want to implement the debug for the... Can I actually Rust derive debug skip members? Is there an annotation that says, yeah, auto derive the debug? What is the status of this? This is exactly what we want, right? Alright, so if we go into the effect, well, it's a program, right? Basically, instead of deriving debug, we derive derivative, and then we say, but for debug, we ignore this, right? Nice that I have it here and here. That's exactly what we want, right? Then we can skip the manual implementation where we have to do everything. But that means cargo add derivative. I mean, we said we use minimal external crates, but for stuff that has nothing to do with rendering or the gameplay, I just say, look, if it's nice to have, I can live with that. If it's just making Rust easier, I mean, So I thought by having derivative debug, I mean, maybe I should have read the documentation. Need to ignore fields. So either this is not doing anything, so the derivative thing is not working. I mean, so it's there. And I think I got the syntax right? So we derive derivative and derivative has debug. So we derive derivative and derivative has debug. Ignoring a field, right? That's exactly what we want. And this is actually a pretty nice so program cannot be formatted because it doesn't implement standard. This would have been too nice, right? I mean, what if we... Do we have to chain this through? I mean, is the only problem that we have to kind of say in the... Why was it the effect? I mean, probably it's just that, right? That we use derive debug for the effect and then the derivative debug in the layer below. And then we have the same in the renderer, right? Because now let's always testing new library stuff in kitchen view. No, 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 no. Well, it looks like this doesn't work. What it does, I mean, this looks exactly... This is what we want, right? I mean, this is quite... This would be so nice. Derive, debug, right? Do we need the macro use? Probably not anymore, right? Shall we just do a quick... before we hunt ghosts? Yes, overriding standard format debug would have been faster. I'll be back in a second. Let's just run the test suite. Maybe it needs nightly features. Maybe it needs some flags. What does lib proc macro do? I mean, this is definitely a feature that should be in base. Well, the only test we actually wanted to run was the derive debug, right? This one here. derive debug. So the test is okay. Is it derive underscore debug? Test name. Cargo. Test name. Oh. Test. Slightly sidetracked. Oh, yeah, I did. So this test is okay, right? So this shows foo42 for foo42 bar because foo. So this works. I mean, do we actually need to do this? I don't want to. I don't want to go there. Must be at the crate root, which is fine. I mean, this is just lib.rs, right? I thought we don't do that anymore. Maybe I was mistaken. Oh, so that was the trick. So in that case, can I just... Oh, we only did it for the vertex anyway, not for the renderer. My bad. So we only change the program and we say, hey, please ignore the shader type, right? That was the reason we did it, and if that works, that will make me very happy. Less writing of debug formatters. Oh. It kind of still... Does it need to be... Oh. Obviously, we probably need to enable it. Duh. No, I don't want to update my watch now. What's going on today? Okay, so this is much cleaner now. So that is step one. What we actually wanted to do is we still get the... Oh, we don't get the linker error, but... Because we fixed the linker error, right? But we removed the debug noise, but we still have it when we want the debug. Okay, so the problem now, how do we get the texture coordinates to the shader, right? So something here says, hey, I don't want to render a quad, I wanted to render a textured quad, right? That's easy, you say. So let's go to the renderer. And where we say add quad, render quad. Let's just copy this because it's 99% similar. But now I have to do something for the add vertex, right? So I could have an add vertex with texture, but I don't want to go there. So I use the old school OpenGL and say self set texture chords, right? And that will get a vector 2. So this will get a vector 2 new 0 0.0, 0 0.0. Yes, I could use a vector 0, right? So this will say for everything following, use these texture coordinates, and then I can just go through and say, okay, this is top left, bottom left, so 1, bottom right, so 1, 1, top right, so 1, 0, right? So we have 2 zeros here. We have these 2 zeros, and then these 2 ones, and here we have 0, 1, 0, 1. So maybe the corners are swapped, but basically that means when I add this vertex, I add these texture coordinates, right? So that means our vertex needs text chords, right? And yes, we are currently we don't care about optimizing memory at this point. We could say, okay, but only if the active material needs them, otherwise we don't write them. But for now, I just don't care, right? So we always, that's room for optimization, right? And basically from XYZ with text chords, right? From, let's say, position with text chords, right? And then we just use our vector 2 here. So this gets a pos, which is a reference of vector. We will make all of this 0 copy anyway, so I don't want to look into this right now. Right, so this is basically pos.x, pos.y, pos.z, and this is basically pos.x. This is pos.y, and yes, to do this could probably be we could just use a vector here, right? So we still need the set function set vertex. Set text chords. You said, right? So if I look down here, maybe we call them text chords everywhere because that's just what they are, right? So we have a set text chords, and that just gets text chords reference of vector 2, And this just means our general texture chords, not the ones for the vertex, the ones for the renderer, right? Where's the renderer here? This is basically text chords as a vector 2, right? Right, so the set tag chords basically says self.text chords equals text chords, right? Okay, fair enough. This should be 0.0 and 0.0. This is just compatibility anyway, so I'm fine with that. We need to vector 2 obviously will always be 0 here. Let's see how we handle z values. Probably we can get away without them. It's 2D anyway. And yes, we can just use a 0 here. And then here in line 220, obviously when we override, we want to override with the contents, right? We're doing far too many, we're copying data that we throw away right now, but it's probably faster to copy two floats too much. Whoa, what have I done? Whoa, nice. I mean, what have I done? I'm gonna get rid of this middle mouse is pressed, right? At some point. I mean, and here's the thing. Step 1, don't call the new function, right? So just don't call this. What have I done? It looks like we're mixing the streams. I mean, it looks interesting, but what the hell have we done? That's this derivative to do. This is, we register the extra render effect. We use the extra render effect, but don't. We added something to the vertex. Ah. We took a shortcut when we did the material, right? So, oh, actually, let's open the material over here. It's already here. So in this, in our vertex buffer, right, we have, ooh, this is interesting. Because basically we're interleaving the we are interleaving the texture coordinates now, and that's technically what we want. But that means we need to tell this, hey, you have to skip some data, right? I mean, what we could just do is say, hey, this is cheating for the moment, right? Basically, we're copying far too much data to the GPU. We're copying the texture coordinates even if we don't use them. And then if we add vertex colors, we'll copy them as well. So you could argue we're copying far too much and we should have different formats for that. And I kind of agree. The thing is, this is a 2D game, right? When will we ever not have textures on something? Now, maybe for effect or something, but so I put this on the out of scope for now, right? Only transfer minimal per vertex data to GPU, e.g. remove tech chords where not needed, right? We can do that, and actually it just means, okay, instead of a vertex buffer, we have a float buffer. And then when we say, basically here, when we say, so the thing is, when we create the material, we get the effect, right? And the effect knows what it needs, correct? Correct. And then we could ask the effect, hey, do you need vertex positions? Yes, I do. Probably all of them do. Do you need texture coordinates? No, I don't need texture coordinates. And then we remember that. And then this is a float buffer, and instead of add vertex pushing the vertex, which relies on packing right now, which is not so good anyway. Let's move this to future. It's not out of scope, but let's not do this right now. So we are lucky that the memory format of the vertex and the renderer, this is pure luck, right? We are lucky that this vertex is actually 5 floats in a row, right? And what I actually want to do is color. Let's just add this right now, right? And technically this hard-coded here is, this is 3 plus 2 plus 4. And that's a hack, right? That's a big fat hack. So, and now we're copying, instead of 3 floats per vertex, we're copying 9 floats. So we're copying 3 times the amount we need to copy. So we'll clean that up. I mean, obviously it's now missing the color. And the color is always white in this case, right? So that's one part of the equation. And we're taking a shortcut here to get to something. Hey, read Rainer. Is it read Rainer or read Rainer? Read Rainer? It's always so hard to guess the pronunciation from the. So we're taking a massive shortcut here, right? And actually I want to get rid of that. middle mouse button pressed while we're here. Just to reduce the noise a bit in debugging. Reed Rayner, how are you doing? Came to see me struggle again? I need the camera here. Did I mention that? Oh, that package didn't. Oh, it's a new wide angle. Okay, that's better. So now we're transferring 3 times the data we technically need. So that's bad, but and we go to, where are we? Here. And we say add triangle, add vertex. Okay. Well, basically add vertex needs to use the actual texture coordinates, right? So from I kind of want to pause with text chords and then we say vector to new. I want to kind of put the vector 2 into the interface here. We didn't have it when we started it, but it's still in bootstrapping mode. Oh, today is not God mode at all. Today is like, let's keep the motion going, even if I feel like just getting some tea and lying in bed. So now we get our texture coordinates all the way to the material, which is nice, but not good enough. So where's our yellow singing? Oh, we disabled our yellow singing, right? So because we saw that breaks stuff. Because we saw that breaks stuff. What do you think about the lens I'm using? Usually I use this, which gives you like this field of view of me, and now I have this see my whole room, and my world basically starts here and ends here. So space. So this is still just one color, right? And there should be a gradient on it if you look at the fragment shader. There should be a gradient because we use a textured quad, and the textured quad actually has a gradient in the texture coordinates. So what gives? What the what? And that's because, yeah, we have the data in here and we skip it, but attrib. This is actually the attrib pos index, right? So we need to enable the second channel, and that is attrib. And I wish I could make this snake, but camel. That, but okay. And basically, we just enable the second channel, right? And right now we enable it for everything. And I'm gonna put a to do here. Only enable when needed. But probably everything in our game will be textured, right? And actually, this only has 2 floats, and the offset here is. Ooh, can I just do? Can I just do 3 times 4 here? Will this work? Hackety hack. Yeah, I just wanted to test how this feels, and in big mode it's actually kind of funny, but in small mode and the green screen is not big enough to cover. But I wanted to test it. So mostly I will be using this lens for landscape stuff. but I wanted to put it in. It's much darker. I have you can see it, but I have the light like blindingly bright here. I'm wondering, there's still something not right. And actually, I'm gonna make this non-transparent for the moment. Oh, you can actually, oh, can you see that? That it's actually very white here at the top and not so white at the bottom. Maybe if we use that for the alpha channel instead, just for a second, maybe that makes it more, I'm not sure. Okay, that didn't work. Maybe I was imagining that this did work. I mean, did I forget something again? I think there's no gradient on it, and I actually imagined that. So, and you see render order problems, right? But we knew that because we ignore the render order. We render in batch order and not in call order. So the mouse cursor is behind, but we can fix that with a layer system. So we believe we do have all the vertex data here, right? Maybe we forgot to copy it. Maybe we forgot to copy it. This is gonna be too much noise. Yeah, so what I will do is I'll disable this loop here for a moment. So we only have, right now we only have the textured quad and the mouse, right? So it should be 2 quads, which will make the vertices easier to read. Maybe we should have a vector with better formatting things. So we do have some texture coordinates in here, but they look like junk to me because the texture coordinates are suspiciously close to the positions, right? Did I make a copy and paste error somewhere in the renderer? Sometimes it's good to debug your data, right? Shall we try again? Shall we try this again? Ooh, colors. That means our texture coordinates make it all the way through. And this looks better now because I get 1 0. Why do I get 1 0 twice? Oh, because the other one doesn't use it. So we stick at 1 0 at the end, but wait, it's 1 0, it's 1 0, it's 1 0, it's 1 0, it's 1. Wait, what? We saw the gradient, right? So this is a mouse position, right? Because it's such strange values. Oh, that's the wrong that's the wrong material, right? So this here, we have 0 0, 0 1, 1 1, and and then we duplicate for the second triangle. We have 1, 1, 1, 0, and 0, 0. So that looks much better. So we do have the texture coordinates now in the shader, which gets us a lot closer to textures. Well, textures need texture coordinates, right? And actually, let's go into the Fiiish app. And just for proof that this is not a fluke, I'm gonna pull this actually in here. Almost. I almost did it. I almost did it right on the first try, right? So we do this, and then basically let's put a bigger one in the upper right hand corner. So let's say plus, oh, all the coordinates are random guesses right now because we're still not working in pixel coordinates, which we will change. Well, we probably use a fake coordinate system so we can ignore the actual screen scaling. So this texture mapping, color gradients currently, this looks right? We have a nice green going up to the right and a blue going up to the bottom, and we have the basic red here. Well, if I go quickly in the shader and set the red to 0, it's probably easier to see. So more green to the right, more blue to the bottom, and then more bottom, and then more green and blue along the diagonal. So that looks right, and now I can re-enable our fancy. I'm not sure why I did this to the semicolon here. I mean, maybe because I like the semicolon. So we tripled our per vertex data, but we added the possibility to transfer texture coordinates. And the layers, the render order, I want the mouse in front of everything. Obviously, we'll fix once we have the texture stuff, texture stuff done. I'm gonna drink some water real quick. Or even better, I bring the water. Well, this is water with juice, but So let's clean this up a bit. Okay, step 1. Let's go into the to-do. What we did, add texture coordinates to vertices, right? And actually we did improve the shader problem debugging a little bit by adding shader source to failure report. Good enough. So we added this for the derivative, yes. Add derivative create for easier debug derives. Right, and then we have this, so that's this one. We updated the to do, we add the add textured effect. That's the registering, and then here we just use it. The renderer actually add path chord and color to per vertex data. I did the save again. It's a reflex when I type text, and that's actually a stash. Didn't want to do. And now I have to stage this again because stashing unstages. So sorry for that. This is a per vertex data. The color is ignored currently. We fixed the vertex attributes. Needs some cleanup. That is remove debug noise from the program. And then we added the 2 new shaders. Right, and the texture lookup is still to be done, but it's in the usual place. Are you ready for more boilerplate? So, we need to get the textures somehow into the system, right? So we need something that loads images, that converts them to OpenGL format, that manages them. So we have an active one. We heard that before, right? If active one, we have a default one. Actually, so we have an active one. We have a way to select the active one. And if we template that, we lose the ability to Rust type name as string. Can we do that? Standard any type name. Static string returns the name of a type as a string slice. Okay, so could we say just for could we just say T? This is a manager for T, right? And this is implementation for T. And here we just say, so how does this work? Standard any type name colon T. Can we do this? And that Can we do this? I mean, creating manager for T, right? Oh, there's a semicolon missing. And actually, where we use it, we need to pass it, right? So in line 56, we say we want a material manager for material, right? And then we can just say it's a manager. I wonder if this is generic enough. Oh, the implementation probably needs the implement T for T, right? Is that the syntax? I never get generics right in Rust. T is never used is fair, because this is T, right? This is basically T. It's still called materials, which is fine, but this is a T. And 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 basically we're gonna. And oh, this is the same, right? One is. I wonder. Actually. And now we can have a texture manager, right? And the effect manager and hmm. Me like. So let's create textures, right? And we go, so the usual sing and dance, pqrst, mod texture, pop use texture as texture, right? And then we go into the texture, pop struct texture, impl texture, pop function. I'm not sure I want a new pun, but let's see how we want textures to behave. I mean, basically what we can go from bottom to top or top to bottom. From bottom to top or top to bottom. Can go from bottom to top or top to bottom. So how would I use this in the app, right? I use a render effect texture and then I say renderer dot use texture. And the question is, do I have to load this texture first, or can I just say, hey, dude, use it? I mean, we could just say test texture 1, right? This is basically what I want as the user. Hey, use text texture, right? Maybe with an extension. But maybe I don't care. This is a logical marker, right? This is not a file name, this is a name. And right now we go lazy and map that to the name, but that is what I want as a user, right? So render this quad with texture 1 and this quad with texture 2, right? That's what I want. So, and then I go into the renderer and we have the use effect. And basically what we can say is pop fn use texture, right? Maybe we want to pass in a string here. Maybe we want to pass in a string. So what if, well, let's just play this through. I mean, what if we renamed the material manager to manager, right? We rename the material manager to just manager. We fix the materials. We rename this to manager. Then obviously we just want a manager here. And it knows what type it is. And then we have, what if we had a texture manager, right? And then we just have a texture manager, which is a manager that manages textures, right? Obviously, if I want to use texture, cargo check, we only wrote half the code down there, so texture cannot be formatted, which is fair because we didn't derive debug. And maybe we want to use this here right away. Right, and then we remove this because there might be data in there, for example, the image data that we might not want to dump. Fair enough. So that works. So obviously, I mean, oh, this is the wrong file. So you have a get active, which is nice. We have a select active, and we had a set active, right? That's cool. So what if textures had a name? And every texture has to have a name, right? There is no way textures don't have a name. Yes, I probably should. So what if textures had a name? And actually textures have a getter for the name. So we can create textures with a name. Obviously, we will need IDs and stuff, but what if, I mean, yes, we could have name collisions, but that is a user problem. I don't care. So when we say use texture, what we actually want to do is let current active texture equals self the texture manager dot get active, right? And then we say if name is not equal to current active texture name, right? Then switching active texture from to almost right. Obviously these are references, and we will probably get a panic now because we haven't registered a single texture. So the user has to make sure what is our default texture. So do we need to register textures? I'm leaning towards saying we have to somebody has to register textures, right? Maybe it's yeah. So Fiiish app. I mean, we use the effect, which is this, right? So maybe we have something that says renderer dot register texture, right? I mean, we could say it's not register, it's load, and load loads and registers, and that will need no. What if we have a texture create that gets a mutable self.system because it might load, and a name, right? So what were the names? Test texture 1 and 2. Test texture 1, right? What if we did it like this? Obviously, all of this would come from a config file that knows what we're doing, and probably we don't load individual textures, but we load a texture atlas, but that then loads a texture and blah. So, and then we do the same as with register effect, right? So so we have register effect. So what if we had pub function register texture? Right, so hey dude, here's a texture. I created it for you. You take care of it. And basically we say, okay, if self dot texture manager length equals 0, then self dot So this has a set active, right? What if we have well, default could just be 0, right? So this could do an auto fallback to 0. So I don't care, but in the register, basically say set active is 0, right? No, we say afterwards, after the insert, we set this. We say self texture manager add texture, right? I hope it was add. Can you just, thank you. Oh, add already returns the, that's even better. So let's index equal this. So if this was the first one, then we make that active, right? Now we need to do the texture create. And the create basically, so that's why I don't want the, we have a create and that gets a system, mutable system. Unfortunately, read-only operations will need a mutable system, which is kind of sad. And this returns itself, right? So right now this is just a texture new name. Minim, just pass it through, right? Don't do anything with it at the moment. Okay, texture is not found. RST texture, which is fair enough, and system is not found over here, right? So we need the system crate here, and then we need GL and stuff, but for now we should be good. Lots of boilerplate basics always are. So hey, it says it's constantly switching the texture, and actually it's not doing it. It should be switching back and forth, right? So this is a bit and basically here we do the same as for the material, right? So we do let found texture self.texture manager.select active, and this will get a T texture, right? And then we say if not found texture. Actually, we panic, right? Texture not found. That is just the name. So this will be called per texture, and this just returns. This basically says. If t.name equals name, right? I missed a semicolon somewhere. Implicit returns are from the devil. So this is switching back and forth right now, right? You can see it's switching back and forth constantly. And basically we could say, what happens if we use test texture here 3, right? Somebody tries to render with a texture. Probably we should use a default texture in that case instead of a panic. Might be nicer for debugging. So this is a panic now. We're gonna use print line warning texture not found using default, and in this case we basically say self.textureManager.set active is 0, right? Not sure about this yet. Not sure if this is the best idea. And I did the implicit return semicolon stuff again. Oh, 8 p.m. already. I wanted to have textures by 10. So we get the warning and it says, hey, using default, right? Which is fine. Let's not do this right now, too much noise. And actually the switching, so at this point we might need to switch, right? So the texture changed. So if the texture changed, this means the material needs to change. Right now it doesn't need to. Let's ignore that for the fact, but one material can render one texture. So a texture switch will lead to a material switch, right? Well, currently it won't. Currently it won't. Let's ignore that for the moment. Oh, let's not ignore that. Let's actually do that part first. So our switch active material, basically we asked the material, can you render this EID, right? And basically we want to say, can you render this text, this EID with this texture, right? So what we want to do is let TID is self dot texture manager get active, and we want the hardware ID, right? Why the hardware ID? I will tell you in a minute. Let's just so we have logical IDs, which is for the fish animation, for example, they're like 50 different textures, but they map to one texture atlas or some texture mega atlas in the hardware, and that's what we want, right? So for now, we just say, okay, pop fn hardware ID self returns U16. If we have more than 65,000 hardware textures, sure, we just return texture 0, right? So we do have the texture ID. So now we have to extend the material and say, hey, can you render this, right? And now there's something interesting. We could just do this, and but we will combine the key, right? We can just say, hey, material calculate key, right? So let's assume we have something that gets an EID and a TID and creates a key, right? So for example, let's just say pop fn calculate. I want one central place to calculate the key and not accidentally calculate it in different places, right? So that gets a effect ID, and we probably should type all of these, and a texture ID, right? Texture hardware ID U16. And let's say this returns a U128, right? So 16 is probably a lot. I mean, what we could just do is have, if I wrote this in nibbles, basically, and the ordering now is important. Let me cheat for a second. Wrong key. I don't want. I wonder how many copies of this I printed already. So basically, the key is just a combination of various different things, right? So it's a texture, it's a render effect, and actually we only have 16 render effects so far. So and there's order in this chaos because later we use it for the render ordering. So let's just copy this and then resync how we will do this. So basically the sort key old Fiiish used this, right? Basically render pass layer was it render pass layer priority? Was it priority? Priority. So you could have something with higher priority in the same layer. We could just use, let's say this is nibbles, right? So we use the lowest 16 bits. So this is 4 bits. This is 8 bits. So the lowest 16 bits is T, right? And then let's say we use 2 nibbles. I mean, a U128 has 32 nibbles, right? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, and then basically times 2, right? This is the space we do have. Maybe 64 is enough, but so this is the stuff we need, right? So we can have, and the key will change over time. But right now we say if texture hardware ID is larger than this, right? Panic, too many textures. Got ID right? And then we do the same for the effects. Too many effects. This is just a safeguard, which probably will never trigger, but and this is basically 255 effects. Probably we have 5. Running out of coffee and getting a dry throat. So I have no idea how to do bitwise. Oh, we don't need to store this, right? We can we just, so what we want the texture ID. So we use a texture hardware ID, a mask that with this, and then shift the result by 0. Right? Yeah, shifting by 0 does nothing, but and then we OR this together with basically the same for the effect ID, but the effect ID is just this, but we need to shift it by this, right? So we need to shift it by 16. Is this just it? And then this basically, this has a key with a U. We probably want a wrapper for the keys at some point. So when I knew it, I say key is material calculate key, and right now it's effect.id, and let's just use a 0 here, right? So we do know our key, and this is the way to calculate a key. And I'm not sure if Rust will like the formatting here. I would like to have it like this, right? Then it's the alignment helps to understand that we didn't do something stupid. Pretty sure Rust won't like my alignment there. And basically can render render just gets the key, right? Can you render something with this key? Basically, this is just self key equals key, right? If the key is the same, I can render this, right? I'm the one to render this. And this ignores the texture for the moment, but basically so this is the key, and then we just say key here. And we say key here, right? And if not, we create a new material. And so the material now on the new needs the texture, right? Probably it just needs the texture ID, but it might come in handy. st texture. And then it basically says texture dot hardware ID, right? And basically this we don't need anymore. But for debugging, we want the texture name, right? So texture.name to string. We don't need this anymore because we have the combined key, and after that it has no value for us anymore. And this is just for debugging. Effect ID, basically nobody should be using this anymore, and texture name is for... Do I sound like an old man rambling to myself? Well, probably I am. And then the debug, obviously. Oh, we could just derive the can derive the debug now, right? We can just do what we did in the program, derive the debug. We derive the debug, but we ignore the vertices, right? That was the only reason why we wrote this manually. Pretty sure I forgot a place. Okay. Okay. Dear material. I'm gonna do it like this. Right? So with all the shifting, and we never risk that this is shifted out before it's converted. So convert to the target format before, even if it's a bit more pricey. So material new needs two arguments, which is fair in line 221 in renderer. This actually needs the texture, so we get a reference to self.texturemanager.get active, right? And this, the effects probably could end up in an effect manager, potentially. And then basically we just steal this and go to 149. That's where we create the default, right? So in 149, this is the one time where we begin a frame and nothing was set up, and I was smart enough to copy the comma. This is just our default dummy material that might not ever be used. In line 169. We used the okay, the material needs the effect ID. The material needs the effect ID, so when it gets rendered, it can actually... Okay, fair enough. Fair enough. I mean, we're copying like 500 megabyte, 200 megabyte of vertex data, so this should not kill us. Right, and actually, let's just do this, and I want to block them like this because this is basically debug information. The program has gone long. I still pre-calculate the key, and then just because we know we need to do that anyway, let's just do texture ID. Just for completeness. Material has no field hardware ID. Oh, true. So I actually want to be explicit here. I want to be explicit here. Yeah. So when we render something that maps to a texture atlas, we need the logical ID to find where that the logical texture has the information where in the hardware texture to find the piece. No? Okay, let's look into data. Oh, yeah, no. Open. Game atlas PNG. So this will end up being a hardware texture, but a logical texture then just says, okay, this here is a logical texture, or this is just our debug block. And that's why our fishes are gone. The fish should be in there. And this is our logical texture, right? So it will need the hardware texture to tell OpenGL use the texture, and we will need to do some when we create the texture coordinates, we will need to do some magic to fix up the texture coordinates to, instead of being from 0 to 1 down here, just be, I don't know, just be this here, right? So, but this is working, and now if we look closely at the end of the render, we have one material that has a default effect with test texture 1, and then we have a second one that has a white effect with test texture 1. Actually, we could say if the effect doesn't need a texture, the texture shouldn't be part of the key, but then they will just all have the same one anyway. And then we have a third material which is textured, which uses test texture 1. So I would expect, well, this is textured with test texture 1, right? And I would expect, as soon as we hit this, so as soon as we hit the use texture, right? I would expect this. Whoa, 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 what's going on? Who's there? Hey! Did you work on Stitch today? I I need louder raid notifications, I believe. Yay! I made more room for all of you, so you all fit into. No, I'm not gonna hug you. Social distance. Stitch is done. Does the client on the proxy on the other side, so the server side, have an API so I can ask it about how full the buffer is? I could use Cheval to kind of put it right here, right? Have a bar, or in the bottom, have a bar down. New camera lens. So I could get some statistics out of it, right? So an API where I can say, hey, give me how good it is. Give me how good the data is. Yeah, I could either do the game or the overlay tool or that. I'll probably, let's see. When I have the fish game in a shape that you can play, I might think about that. I really am. So we are basically, for the new ones here, we are basically taking my very old fish game, 10 years game jam weekend, and then it's actually launching, which was written in C++ and has multiple rendering backends, so Metal, OpenGL, OpenGLES, there was a Vulkan renderer and a DirectX renderer, and we are writing all of that from scratch. And I really need to disable that breakpoint because I always think it crashed. And we killed the fish, which is basically this fish here, but we're doing all of this in Rust. And right now we're abstracting away the rendering. Well, yeah, I won't be able to get remote stats when the network is down, but when the network is back up, I could get stats, how many times the network was down, right? Or stats, how low the buffer got, so I can tune my settings to increase the buffer if my network is really lousy. So basically, that's I did this game for Game Jam, I think 10 or 11 years ago, over a weekend, and then used that as my test bed to develop all my tools around it and all the frameworks around it. The fish is we killed the asset converter accidentally. Sorry. The fish is up here in the corner. The fish swam out of the game and onto my overlay. But we'll get there. So I had that open a minute ago. If I look at the game atlas, actually the fish should be in the atlas, but it isn't, so it uses the default texture, and I have no idea. But we'll get there probably Thursday, I would like to say. Maybe Thursday when we do animated textures. I would love to say Wednesday, but Wednesday is not gonna happen. So all week long I have a vacation and I'm stuck in this tiny little room here, so what else do you do? So right now we're trying to figure out in theory. So right now we have three different render effects. A default one, a white one, and a textured one. And two textures. Textures are not loaded yet, so if I run this, I have the default one, which is a rainbow thingy here. And by the way, this is 500,000 triangles right now. We have the white one, and we have the textured one. So the texture coordinates arrive, and we're just hooking up the textures. What I don't get, I would expect one material for the white stuff, one material for the rainbow stuff, one material for the textured stuff with texture 1, and one material for the textured stuff with texture 2. But if I look at the debug output, I get one material with the default effect and no texture, so the last used texture. I got one material with the white effect and the test texture, and then one material with the textured effect and the test texture. But I'm switching textures here, so I would expect this use texture to say, hey, I don't have a material that can render this. Can we just... So somehow the use texture code here, and I know the switching is working, right? Well, it tries to do the switching. It tries to do the switching. Come on. So it tries to do the switching because it switches from this texture to this texture. It tries to do the switching, but then somehow doesn't do the switch. So switching material after texture switch, right? Oh, yeah, it doesn't. So here's the thing. We say it will go in here, it will get the effect ID and the hardware texture ID for the texture, create the key out of that, and then say, hey, can the active one render this, right? And so part of the key is the texture ID, the hardware texture ID. And right now, all textures have the same hardware texture ID. Yay! Out of water. Out of water. I need to refill my coffee. I'll be back in 5 seconds. Kitchen in darkness because my kitchen light disconnected from the internet and there's no hardware override button. Well, none that I can reach. So we need to stop this from. So right now, I mean, we have a hardware ID, right? So man gl gen texture, right? Textures. So this will return a GLU int, right? And the type is just as in the pro. I don't want to type the whole bloody thing, so right? So this is the hardware ID. So probably let's just pull this in. So this just returns self hardware ID as U16, right? If we ever get one that's higher than 65,000, we're in trouble. But the calculate sort key will let us know, so no need to check in 15 different places. So when we create a texture, let me just say hardware ID is this, right? And technically we could just do a GL gen textures. Oh, it wants a pointer. Ugh. I'm thinking 2 steps too far ahead, so I'm gonna stop that right now. So let's mutable hardware ID equal this, right? And this is just hardware ID as U16. Oh no, this is just hardware ID. Internally we use the full thing and then we use a GL, that's unsafe. Unsafe GL gen textures and give it the mutable hardware ID, right? Well, it probably wants a 1 first. It wants the number of textures to generate, and we just want 1. So now the hardware ID is the actual thing generated by OpenGL, even if we don't load any data into it. So I want to see at least the switch happening. Oh, we have too much noise now. What did I mistype? Matter of habit. Years of training. 25 years of typing GL functions. It's just muscle memory by now. So, okay, the switch is making too much noise, so let's remove this. And now they should have distinct sort keys because they actually use the texture hardware ID. So now we have one material, default test texture, white test texture, texture test texture, texture test texture 2. Interesting. Interesting. Why do we have all the combinations? Oh, because, so, we probably should always start the frame with a defined state, right? So let's use test texture 1 at the beginning of the frame. Then we render all of this with test texture 1, but switch between white and default. Then we should have textured and test texture 1, and then textured and test texture 2, and then we switch back to white, but probably we should just make sure we have the defined texture, right? So we had too many combinations because we were lazy with our state cleanup. And we would have seen that if we actually had textures. So we have default test texture 1, white test texture 1, texture test texture 1, texture test texture 2, and white. Who's using white text tested? Where does this combination come from? Who is using white? I mean, we can see the hardware ID here is 1 for 1 and 2 for 2. So who is actually, when is this one created? So white text, this is textured, right? So when do we, oh, okay. So here we switch to white and test texture 2 is still active. So we create the material and then we switch right away. So we create an empty material for the combination. You could argue that you should always use the same order of defining things, but I mean, we're putting in a million of triangles and vertices, and we have one empty one. We could actually, in the material, say when we render it, we could say, hey, if the vertex count, if the vertex count equals 0, return 0, right? So skip all the setup and binding stuff if you end up not doing anything with it. At least early out. This will still generate the material, but it will not be rendered. So all of this is nice. So this step I dread a little bit. We need to load the image, right? We need to load the image. So I need to go black screen for a second because I have no idea what project currently is open in Krita. If Krita ever decides to open up. Krita, my dear. Okay, so remember all of this? Oh yeah. So let's create a new one, right? Let's create a texture. Let's say, because I like powers of 2, 64 by 64. That sounds good. And let's put some test colors in there because colors are. Can I get this bigger? Can I just get a normal color selector? Okay, so let's put some red in one corner, some blue in the other corner, just to make sure our primary colors are right, and some green here. And actually, let's put some black down here. And then we put a big fat, big fat 1 in here, right? I typed 1. Can you just... That's not a big fat 1, so let's make this a big fat 1. I don't care. I don't care, right? So let's save this as PNG. Yeah, let's just save it in my user folder. Test texture 1, right? Yeah, I don't know. I don't care. Forced to a store alpha channel. Fine, right? And then we added this. Oh, we can't. Where's my... Oh. Thank you. I'm going back to the GIMP, right? I'm just going back to the GIMP, so... And then we just say file, save as, test texture 2, right? Yep, I know. And then I just close. No, 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 no. And then I copy tilde test texture dot png into Fiiish data, right? So if I open Fiiish data test texture, I do have both my test textures, right? Easy peasy. All we have to do is load them now, and I don't want to. Well, we set 10 p.m. today, which is in 80 minutes. We have textures loading, so I would love to write the PNG loader from scratch, but I will not do this. So what we will do, I mean, basically we have the texture has a create, right? So we have a create, and then basically let's put this down here. Function load from load that will meet the system. This will need rework, and we just assume this always works for now, right? So then we say tload system name. Thanks for the broken autocomplete there. Right, so, and here the loading happens. So we need to find the file, right? So we need to check some extensions. So let extensions Let's just say this is an array, and right now we just support PNG. Find for the search. This will come from a config file anyway. So let's say for E in extensions, we say let f equals system dot get default. I have to cheat. System get. Oh, it's not a get, it's default file system, right? And then the default file system, it's basically the file system trait. We have an open, right, which will always give us a stream. So we have we have a format, and that's this, right? So it's a name extension. Let file name, let file name this, and then we say open file name, right? So this will always give us a file system stream, right? And then a file system stream could be valid or invalid. So let's say if not f is in, well, if f is valid, right? If it is valid, then we print line loading from, basically, right? So we say loading name from file name, and actually let's put .jpg just to make sure we hit the wrong one first. And that basically means something will have happened here that we return, right? And in this case, maybe we want a bool here. Maybe somebody cares, but nobody should, because this is just for debugging. This is just for debugging. Let's borrow this. We will not do the auto append extension. We will have a lookup table that says, okay, test texture 1 is actually in this data set, and oh, this is actually fair enough. I will steal the image loading stuff from Cheval. Yeah, probably, because I'm too lazy to. So when we register the texture, loading test texture from .png. So we got the file, right? So we need a reader now. Okay, so we said we steal this from Cheval, right? I mean, no need to reinvent stuff we did 2 weeks ago. So we have an element, image element, right? So I steal all the image loading logic from here. Do I? Do I? Yes, I do. So cheat mode enabled, cargo add image, and this will probably add the 2314. 2314 for real? 2314 27. What? I hope this didn't break anything. But we're not gonna figure out how this works. We're just gonna load it and oh. So here's the thing. Image open gets a file name, right? But we don't want... can we actually open from a reader? Functions. Load from memory. Load from memory. Oh, maybe we want a reader. Do I want to implement a reader? Do I want to... I need a 5-minute break. Sorry, the neighbors are making a ruckus. Maybe they shut up now. Maybe they do shut up. So if we implemented the buffered reader, I'm not gonna implement a buffered reader. I mean, maybe we should. Maybe that's future add buff read and seek to trade to a file system. Well, actually it's file system stream, right? And that would be super helpful, but right now we're gonna step... and we're not gonna do it in 1 hour, but we can do load from memory, right? Create a new image from a byte slice. Makes it TGA is not supported. That's fine. So it needs a U8 buffer, right? So load till the end. We probably just add map support. So what if we go into the texture? Still fighting with Rust more than I would like to. So what if here we could say f.map map and then actually do f unmap, but just implement drop and we're done with it anyway. So what if this would just give us exactly this, right? And I do explicit type right now, and then we could just say image load from memory, and that's a freestanding. So we could just say image load from memory. We need to do the import, image load from memory, give it the buffer, and then do something with this, right? Let I equal, but let's get to that step, right? So obviously the file system stream has no map right now, and that ah so this is interesting, because I thought this is not nice. What the? Oh, map is probably I mean, it's probably mem map, right? Memory map or lock or mm, how would you do this in Rust? We could just how would you do this? I mean, we have to read a string, right? I mean, worst case, we could just say, okay, I mean, let's buffer equal vec new, right? This is a highly inefficient way of doing that. And we say while not file and a file, right? While not file, let character equals f dot read u8, right? And then we just say buff dot push c, right? And then this is just buff dot into. Can we just do into? Can we just do this? I mean, this is a hardcore copy that builds externally. The file system stream should support this, but it doesn't currently. We probably could say as pointer, right? As slice. Can we do as slice on a vec? I never tried that. Obviously, we want to push into this, right? We want to push into this. And the F is not mutable. Yes, it isn't. Wow. So what I will do now is debug %i and to do die, right? I just want to see what image says to the junk we gave it. Oh. I mean, all we need is... This is actually not too bad. Yeah, but I don't have a buff reader. So our file stream here abstracts away various file systems. One of them is a disk file system, but I haven't implemented buff reader on that. So I can't use buff reader because it's not implemented. And that's actually what I meant with have all of these. Which I guess is fine for today. We spent yesterday and the day before going a lot of sideways and extra routes, and why is this compiling forever? So as soon as you pull in the image crate, compile times go ballistic. I'm pretty sure there's something seriously wrong deep down in that thingamaboo. I mean, oh, so it looks like we get some pixel data. I mean, it's mostly white, but there is some. So we got some pixels. So that is. No, it doesn't implement the read trait yet. We just wrote that yesterday from scratch. So no read trait. It probably should. It probably. Yeah, maybe you're right, and I need to add read buff read. Add seek. Well, seek technically is there, we just haven't wrapped it in rustiness yet. So I want to know, so this is an image result, right? What is an image result? An image result is a result or an image error, which is fine. So we can do a, actually let's match directly on that. So it's either an error or an okay, right? So it's an error E. In this case, print line error loading image from this. Error this loading image from this. So it's E file name. And in that case, we just keep iterating. So folks, I'll create a broken case in a minute. Or it's an OK, in which case we get an I, in which case we'll do something with it, and basically the it is this, right? So what I want to do is let's actually use the test texture 1.jpg, not a JPEG. Right, so if I run this now, the image loader should say, yeah, I tried, but nice try anyway. Okay, maybe if I don't debug all the pixels, I might be able to see my output. I wish image had a formatter that kind of formatted a bit nicer, but basically error the image format couldn't be determined loading image from test texture. Well, it's a text file, so it's expected, but at least I just want to error. So we have an image. So what do we do if we result of T? So it's a dynamic image. How do we get? I mean, we need RGBA8, right? So we have a dynamic image. We can do 2 RGB8. That's nice. So what we can do here is let I equal I2, what was it? 2 underscore Do we also have a 2 RGB A8? Yes, we do. I mean, this is close to a GL image buffer, right? And then the ugly starts, but yeah, so we get, so now we got an RGBA image, right? Well, we got an RGBA image, and that is just the image buffer, and the image buffer, I mean, can I get the pixels as raw into raw? As raw, or I mean, let's get the width and the height, right? That's step one, and I was smart to do it was so smart to do a square image, but it's a texture, so I didn't have much choice, but so I hope this is 64 by 64, right? I mean, so close. So this is a version that loads a hard texture into so yeah. So if we look at I printed again, stupid editor switching. So we have a texture metal. That's actually texture OpenGL, yes. Should be similar. So we bind the texture, we do a tech image 2D, and we set some, and we generate bitmaps, right? So all we need to do is this. So we bind the texture. So if we got this far, we can actually go into OpenGL mode and say GL bind texture, and just for, yeah, that's not the window I wanted to hit. So we bind the texture, and the target is actually GL texture 2D. So we bind the texture to, well, that's GL texture 2D, and this is self dot hardware ID, right? Hardware ID. So we bind the texture, which we created earlier, right? We created it here. So this basically allows us to reuse textures. And then we do the classic GL tech image 2D. 2D, and that gets a bunch of stuff. And that's why we cheat and copy these 3 lines here. Texture, yeah. Just for reference, so we don't have to fiddle around too much with the GL, because this is a port. This is not a rewrite from scratch. This is just a port. And potentially we only use the GL tech image 2D, and this basically says now take this data and make a texture out of it. So it's GL texture 2D. The next parameter is the level, so mipmap is 0. The format is RGBA. And this is actually the internal format. You could argue that we don't want RGBA 8 all the time, but we don't care. We assume width and height are powers of 2 and it is square, so if it's... Oh, they don't need to be square, they don't necessarily need to be power of 2, but we will assume they are. And then we have the border, so the border is 0. Whenever I do naked values, I want to know what it is, and then it's the format of the pixel data. So it's GLRGBA. And then the type is unsigned byte, right? So just 8-bit, 8 naked bits, unsigned byte. And then we actually need the data. And that is probably, I hope, can we do as raw? I'm not sure if as raw. I mean, probably. I'm sure the underlying data. I mean, I'm not sure the underlying data. Let's stand on giant's shoulders, right? We know that glium does something like this. So source, texture, is glium actually using image? It's using image, so are they actually using 2RGBA somewhere? Yes, they do, so that is not the code I was looking for. So it does an image load, it gets it, and then it just creates a texture from RGBA. So into raw seems to do something rightish. So what's the difference between into raw and as raw? I mean, you could just try, right? You can just say into raw and see what the compiler says. I mean, I'm just worried that there's stride or something involved that will totally mess us up. The double GL again. The double GL got me again. 50 minutes is gonna be tight. So this, well, okay, the widths and heights needs to be I32. I mean, if we have an image that needs more than 30, is more than 2 billion pixels wide, well, we have a problem. And here we can just say as pointer. I'm just cheating now. This is just pure and raw cheating. I just want to see if anything crashes. Expected C void. Okay, can we just do into here? I mean, I could just do as const star underscore star const underscore, right? Or we could just expected I32 found U32. Wait. Wait. Is this wrong? Or is this wrong? What we will do is we don't want to pull in Gliom for because of the interface, but that doesn't mean we don't want to. I mean, they're open source, we're open source, so I have no problem. Where is this? So image.rs. Where is this actually defined? There. I just want to see if there's snakes in the grass. So basically, ooh, so we don't need the reverse, right? I mean, it's just the data basically. So this just flips it upside down, but we don't care about it. So I mean, so let's just give it a null pointer, right? I'm not sure why this doesn't make any sense. Try into unwrap. Where line 68. So I think the bindings might be bad. Now this is tech image 2D, right? And this is the third parameter. The third parameter is, this is too wide, so this is a target, which is an enum. This is the level, which is an int, and then the internal format is an enum. And then this RGBA is, oh, this is compressed. This is an enum. So what is your problem? Internal format is GLRGB. I mean, yes, I could use GLRGB8, but what is wrong with that binding? Expected I32 found U32. Yeah, yes, because it's, what am I missing? Running out of juice. I thought we were so close. So they also do the explicit I32, but that's weird, right? Because we passed the enum where we expect this enum. That is weirdish. Wait. Oh, it's standard pointer. But maybe let's not die here. And we have the debug, right? So we could just do a GL debug check error. We could just do a check GL error after this. Fine. Yeah, not in the comment. This should result in an error, right? Because we try to load the texture from a null pointer. This should fail. Oh, we didn't import. Well, we did import debug, right? Oh, obviously it's debug check GL. I'm running out of juice. I am running out of juice. Are you too? Do do do. This should throw a GL error. So loading. GL said this was fine. Okay. So let's just do this, right? Let's just give it the buffer that I think might still be bad. I mean, it's not using it yet. So it's not using it, but all we have to do is basically, and we already looked at that, so when we have, where is it? We have a bind, and that basically says GL active texture. So we do a bind texture, texture 2D, and then we probably need to do the channel, right? So man GL active texture. So in the texture somewhere, this texture probably needs a pop function and bind to channel. Well, we don't care about channels right now, right? So we set the active texture, and the active texture is always texture 0. We just make sure. So unsafe GL active texture is GL texture 0. Always, let's say, to do support texture channels, and then we do a GL bind texture, and that's just the target, which is texture 2D and the hardware ID, right? So GL bind texture, and that's the texture 2D, and that is basically self.hardware ID, right? So this is the bind. Well, this is still not enough, but what did I mess up? Oh, I'm starting to make the same mistakes as last night, so it's probably time to wrap this. It's probably time to wrap this. Okay, so we're loading the texture, we're syncing, we're putting something into texture memory, and if I run this now, it's still not working because we're not calling the bind and we're not using it. So So here is the thing, what the renderer needs to do in the end. I'm missing keys on my keyboard. I have to abort it soon. So when we render, we make sure the render effect is actually come on. When we render the material, we pass in the render effect. So the material actually ensures the effect is used. So now we have to pass in the texture, but we don't need to pass in the logical texture, right? All we need is to pass in the, well, technically the material knows the texture ID, right? So we could just say, no, this probably can go now because it's gone so long. GL active texture is GL texture 0, and then GL bind texture, GL texture 2D, right? I mean, we we are new material, so the probabilities of the texture being correct are pretty low, so we avoid the whole caching dance. So, and that would work in old school OpenGL, right? So the texture actually doesn't need to bind itself. It's not, it's texture hardware ID, right? So if somebody unloads stuff in the rendering loop, well, mismatched found U16. That is fair because we truncate it. We'll handle overflow at some point. So if we create and destroy a lot of textures, this will blow up in our face, and it's still not doing the sampling, right? So, I mean, but it's not doing the sampling, right? So if I go into, and I print again. Render effect, textured, where is it? There. Oh, wait, we need the, I want to open the shader, right? So data, work, OM, fish, data, render effect, textured, fragment shader. So basically this is what we want, right? So we have the texture coordinate, and maybe we could make this varying to get the interpolation. So we need the sampler. So somebody needs to set the uniform for the sampler, unfortunately, which is so close. And then we just do the texture lookup based on the texture coordinates, right? I'm not sure why this is not GL frag color. So this is, and I fucked up the wrong shader. I messed up the wrong shader, sorry. Textured fragment shader. This is a much better place. I mean, so basically we want to do, this is the only line we care about, right? So this is the tech chords. And we want the uniform for the sampler, which I wonder if we can get away without setting the uniform. Maybe we just get lucky. I mean, the varying is the more... I mean, so maybe this should be, instead of in, should be varying. And then we do the... Oh wait, that's... mixing OpenGL and OpenGLES here. Oh, now it's white. Now everything is white, right? So it looks like it's doing it. Well, let's see. Failed linking shaders. So failed linking shaders. So it's not the first part. OTech chords. Why is it failing? So okay, so this shader has some problem. What is your problem? What is your problem? All we changed was the... We added the uniform. we won't get around getting the log files from the shader output. I wanted to avoid that, but okay. So we're getting this error here, right? We're getting this and it says to do get actual logs. So how does this work? We have a GL get shader IV, right? So basically we allocate a buffer that is big enough. And then we... Wait, this is for the compile shader, right? But the compile shader is the one that's failing, so... I don't want to go there. So here is the thing. Basically, this is what we need to do, right? This is straightforward in C++. So we have GL get shader info log. We have GL get shader info log, but that gets a pre-allocated buffer, right? So that gets a buffer that is big enough. I mean, we could just do let buff equal vec with capacity log length, right? And that is of type, is this templated? Templated, generic. So we could do this, probably. Okay, that's good enough as usize. I can do that. Rust create great memory buffer. Create memory buffer with fixed size. So I'm reaching my fringe knowledge of Rust now. Memory management. Yeah, no. Do they actually do the get shader log info? I have to buy these guys some drinks at some point. Oh, they do. So all I want to know is how do I get the buffer? So arrow log as mute pointer, yes, fine. But where's the arrow log created? Oh, it needs to be mutable, and we put the type information in the front. So we were very close. I mean, so wrong place for the type information. Fair enough. A bit sad, and this needs to be mutable. And then we basically do what we wanted to do, the gl get shader iv get shader info log, and that will need the ID. Right, this is this ID, the shader we're trying to compile. The probably it's better to use, I mean, we use the capacity of the buffer, right? Which should be the log length, but if this for some reason failed, this might be dangerous. And then we just get that as a mute pointer, right? Yeah. So we just get the buffer as mutable pointer, and I'm probably sure we can just do this. Some type problem probably. Ooh, ooh. Isn't it buff? Wait, what? Buff dot capacity. What did I do? Oh, wait. Wait, the signature is wrong, so it gets the, so this is the length, and this is the actual log length, so it's basically this. Not sure. Maybe we just do log lengths for readability reasons. I mean, we pass in the value here, and then did I mistype shader info log? What? It's the ID, it's the log length, and it's the actual buffer. Expected one of 7 possible tokens. Maybe write a pass separator here. What? What are you? I mean, if we just get this as a mutable pointer, right? The type will be wrong, so we need to cast it. But why is the dot not working there? Why is the frickin' dot not working here? Why is the frickin' dot not working here? So now it will tell us, hey, the format is wrong, right? So oh man, there's a colon missing here. That's why that error message was totally useless. So now it's saying, hey, expect an expression because I forgot the s. Mutable something. Okay. And all I have to do is print this, right? Oh, let's just dump it out for now. I mean, we basically we do the from so basically come on. So we could say let s equals string from UTF-8 and just use the buffer, right? And then we just print s here. Dot unwrap. Yes, it could fail converting, but if our OpenGL driver gives us broken UTF-8, we're in errorland anyway. 20 minutes. Too much debug noise. So what is the problem? So the linker fails because the compiler fails, and the compiler fails. Warning, log length for shader fragment. Yes. Warning, log length for shader fragment. Error log is... Oh, okay. So buff set length to log length, right? So we read into that buffer, into the capacity, but we didn't update the length. So it thinks it's length 0, so the string it's a bit weird, but we won't abstract away OpenGL every day, so it's kind of exciting a little bit. So where's our error message? Error log, invalid call of undefined, undeclared identifier texture 2D. Wait, what? GLSL texture 2D. So texture 2D, and this is basically OpenGLES, right? So OpenGL, GLSL. We don't want GLES, so we want this. That's probably not the best. Oh, this is Chronos. Where's the spec? Current specification. Really? OpenGL core profile. Shading language 4.6. I mean, technically we're using 3.3. Can you open this? Oh. PDF. Thanks for internets. I'm not even sure I can show this. Well, oh, it's an official spec, so I just... Can you? Wouldn't it be nice if this was just a web page? Texture functions. So I did only metal in the last few years, two-ish years. So texture functions, texture lookup. We need the sampler, texture query sum. So where is texture size? We don't want the texture size. I just want the texture lookup. It's just texture. Use the texture coordinate to... Oh, so it's actually, it's not texture 2D, it's just texture because it's OpenGL and not GLES. Almost. I mean, we don't get an error anymore when creating that. We get black pixels because we are using the uniform and we don't set the uniform, right? So if I go back to my Xcode project, GL uniform, this is metal, so basically we need to look up the, so a GL uniform 1i, right? So man, GL uniform 1i needs the location. So I could just go in the material and say, hey, by the way, GL uniform 1i, and basically uniform 1i, thank you. We basically set the channel, so it will probably be a comma 0. And I wonder if the location of the uniform is 0. We're just shooting in the dark. Technically, we need to look it up. Well, we could just look it up, right? We could just look it up. I'm just rushing for time. Restart your Windows now for an update. No, thank you. So, the thing is, we can look up the uniforms, right? Where's my Xcode? Thank you. So, these are basically... so basically we have GL get uniform location, right? And that needs the... So basically we need this, right? So what we could do is we have our program. We have our program, and technically the program should do this, right? So technically after the linking, not before, we have a pub function get uniform location, right? And that is self, and that needs a name, right? And that will return I don't know, man gl get uniform location, and that returns a gln, so u32 is fine. I don't want to expose, so let's just do a 0 here for the moment. So what we could do is we have something like uniforms, right? The question is who owns the list of uniforms? The material or the shader? So I wonder, where's my PDF? So I wonder, get, that's the wrong. I wonder if there is a get all locations. No. I think in the newer GLs you have a hey, get all uniforms. So I wonder if, what if after linking the program, so what if after linking the program, I don't want them here because basically we're doubling up the information. So what if after linking the program we do look up common uniforms, right? Probably it's configuration, and the new could just know which uniforms to expect. So unsafe. GL get uniform location, and for example, this is so for all shader IDs, right? For all shader, we don't need to edge. For all shader IDs, shader ID, we get the uniform name, right? So UN. And here basically we have let uniform names, and that is just let's say we have texture 0 in there as one of them. We just use common ones and just load them all. The new OpenGL allows us to get the used ones, but so we just say for UN in uniform names, we do this, and get uniform location will return glint. So let L equal this, and what will it return if it's this function if the name does not correspond? So if L not I equals -1, right? Then we just do print line got uniform at location this, right? So we say UN L. Just debug for now. just a debug, and actually this is to do. So when we link a program, we check all relevant shaders. Okay, yeah, we need to. Well, I'm not sure about the idiomatic way of doing this. Mismatched types, I mean, we're so close, so okay, fair enough. Running out of juice, did I mention that? So get uniform location expects an I8. Man, GL get uniform location expects a GL char, right? So as pointer const something, right? Oh, this is probably not zero terminated, right? So I forgot the S. So this probably needs to be zero terminated, because GL doesn't know the length, right? Too much debug, so GL error, invalid operation. Okay, so invalid operation. If we need the program. We run it against the program and not against the shader, right? So this is program. My bad. I mean, that means we can remove this loop here and just use the self program ID here, which is much nicer. Yeah, my back is giving in, so I have to give up soonish. Got uniform location texture 0 at location 0. So our hack here actually should have worked. So this is not how I would want to do it, but obviously we could store the uniform locations in the program and then ask the program, hey, do you have a texture? Do you have this uniform? If yes, I need to do something with it. So two potential problems. A, this is actually our data, but it's broken. B, something is wrong in the... So basically this here. Oh yeah, metal. If we have it, we set it, right? So this is when we bind the render effect, and actually the render effect knows the uniforms. That is interesting, because the effect shouldn't. The material needs the connection, and so after using the program, we bind the uniform, right? This is so long ago, I forgot how this works. So what is texture 0 in this context? That's the channel. That is the channel, right? So I'm leaning towards our setup is correct, but our data is broken. So what if we just go into our texture and instead of all, what if we had a let dummy buffer equals array of a white pixel. Let's make it the white pixel, a black pixel, and then the same thing again, right? Just 4 pixels, just 2 by 2. This is easy, right? And then we say this is 2, and this is 2, and this is basically dummy buff as pointer, right? As const something. Maybe our data is bad. Oh. Does not fit in I32. No, it's really? Really? You default. Okay. Keep smiling. 2 minutes to texture. So so let's check this. So what could be wrong is that our texture coordinates are just 0, right? So what if we do a vec4 of 0 O tesh chords x, O tesh chords y, and 1.0, right? We just don't use the uniform, we just use the, so our texture coordinates are correct. So what else could be wrong? I mean, maybe our texture 0 is not bound correctly, right? But we are binding it here, right? So what we could do is, do we actually have a what we could do we actually have a GL error when loading the texture? No, we don't. We might not have mipmaps, but that's just optimization, right? So in texture we bind the texture and we do a tesh image 2D. We have the active texture, so I haven't done OpenGL in such a long time, so yeah, that's good. Model loading, advanced, getting started, textures, right? So we pass the texture coordinates, yes. We assume that the default mode is okay. I mean, maybe we need to set it. Filtering, yes, we should set. We don't have mipmaps created, so that could be we generate the textures. We bind the texture. Maybe we need to do the generate mipmaps, right? I mean, maybe it's so long. Is it just texture 2D and then it's just texture 2D? I mean, it shouldn't matter, but maybe it looks up a mipmap level that is just empty because we never created it. There was an error somewhere. And I did it again. Yep, we're officially 2 minutes over the time limit, so daily goal, no success. But I think we're it's one of these, I shut down the stream and I find it 30 seconds later things. Oh! So it was our missing mipmap levels. It's still not the black and white thing I expected, but now we can just say, hey, maybe we don't use our dummy buffer, and just use our real buffer and see what happens. We want to disable filtering anyway. So, oh, so it did have empty mipmaps. And even the orientation and everything is right, so we got textures just 3 minutes late. Chaka! Whoa, long day. Obviously, this here is not gonna fly, so what I will do is, in the program, I will say uniforms is actually a hash map of string to U32, right? And then this is an option. Well, okay, let's turn this around. Let's just say pop function uniform iter, right? It's just a self type to be defined. This is self.uniforms.iterator, right? So if we get a uniform, what we will do is we say self.uniforms.insert drawing a blank un clone comma l, right? Can I get a check, please, in my history? Check, please. Check, please. Yes, so self-program use not found in... Oh, because I didn't have a return value here. Lazy boy. Boy as a little human male being. Missing uniforms, okay, fair enough. I want it before the shader sources. Then... oh, toString, not clone. I'll probably clean up the cleanup I'm doing right now tomorrow, but that's fine. We almost have uniform support. Found I32. Okay, let's do an I32 here. And that's fine. And then obviously we want a standard hash map iter. Actually, we want this. That's the part I'm always too lazy to type, so I just put a U8 and the compiler will tell me what it wants, right? So including the lifetime lesion, because it knows that's the lifetime of the, well, it knows. So Yeah, that's because we fixed it afterwards. So this is nice. So what we can do now is we can say effect dot program dot uniforms iter for, and that is probably just in name comma location. We say print line just to be sure we get them right. I'm not sure if the effect exposes the program. Probably not. Private field, not a method, but the effect, yeah, it can hand out the program in a non-mutable way. So we have a pop function program self reference to program, and that's just self reference to self the program. I need macros for this kind of stuff, really. Auto create accessor for member variable. Oh, name, not. Yeah, obviously I wanted to use the L here, which I already use here, and not the N, which I'm pretty sure the distance from N to L is even shorter than the distance from L to U. So if I run this now, I dump this every frame, which isn't the smartest way of doing it, but so texture 0 goes to texture 0. So what I can do is I can match N, basically say texture 0 if I can, and if it is texture. In all other cases we just ignore the uniform, right? We do a GL uniform 1i, and that is the location comma 0. Always use channel 0 for, so this is this here, right? So we could do +1 here and then it would be channel 1, but we want channel 0. Use channel 0 for texture 0. This is nothing OpenGL dictates, but it's something we decide. We could make it dynamic and configurable, but in the end, it's a 2D game. Everything has a single texture and one texture only. Yeah, I still write Ruby code now and then. Sorry about that. Can I do that? Rust match string to string. Well, that's probably S string. Never used that before. Today I learned how to write bad Rust code. Almost. And it's obviously GL uniform. So that means all the other uniforms, I mean, projection matrix. Projection matrix, anyone? Oh, nice. Animation stuff. So how if we put the texture on the white stuff instead of just to show that this is working as expected. So all we have to do is basically instead of white we say textured, and we render a textured quad, right? We transfer the texture coordinates always anyway, so textured. All we need now is a good looking texture. And we still have the material support and everything is working as expected. I'm gonna change the middle mouse button real quick because right now it's pushing 1000 on middle mouse button. That was for the load test, but we don't need that anymore. Whoa, look at this. We have textures. So I'm gonna do one thing real quick. Data work. Content. Fish. Who deleted those files? Did I move them accidentally? That's why they're broken in the. Oh, we have them here, right? Stream overlay date overlay Fiiish anim. I accidentally moved them. That's why they're broken in the Xcode thing. Let's say we copy this to just fish data, right? And then we say, okay, register texture. Oh, the sad part is file dot fish data fish swim. Oh, it's square, so we are in luck. So what if we register a texture that's called fish swim 00, right? Let's register this texture. And actually, what could go wrong, right? What could possibly go wrong? Why do I always write texture and text instead of textured? Always the same. Oh, why didn't it load the fish texture? Loading texture. Loading fish swim 00. Hmm. Something goes wrong when loading this texture. Oh, there it works. Oh, maybe we should give this some texture coordinates. Obviously, aspect ratio is still totally foobarred, and we need to fix that next. But now that we have uniforms, we can pass in. Look, a fish. Looky fishy. Looky fishy. Come on. Come on. We can do better than this. We can just use... Uh-oh. Now we're breaking it, but I'm having fun. And I need to go to sleep. Yes, Siri, I know. Looky, looky, loads of fishy. Let's scale this a bit bigger and actually just make one out of them default to have some. And well, we can just do this here, right? Lots of fish on the screen. Loads of fish. And my default thingy is gone, but why is my mouse click thingy gone? Because here we render the click positions, but we don't do the setup, right? So it tries to render this quad with the fish without the texture coordinates. And maybe we always render textured quad. Well, maybe not. Maybe not. So who do we rate at the end of the day? Look, my fish can draw. Loads of stuff. Oh, the old engine doesn't support texture flipping, so we can't swim left. I never realized that. Let me actually... Oh, this is not working. Okay. We got a fish, we got a fish, we got swimming fish circling around my hat. I am going slightly crazy, but this has been a very long day, very long day, very long day. So, we can render textures, we get keyboard input. So tomorrow let's actually write this down. So, let's look at the to-do, right? Render quad with texture. I would say done. What we also done is add initial uniform handling, right? That's what we did. What do we want? Do we want animated textures? I mean, we totally kill the batching, but probably we do want that. Add support for model view projection metrics, right? Well, it's probably just VP. So this will need add very basic matrix struct. So I'm not sure if it's a 4-4 or 4-3. Let's just say matrix, because we need that for mass anyway. We have the rendering. Set up correct MVP for auto graphic projection. Thank you. So that's what we're gonna do tomorrow, and then add basic Fiiish movement. So tomorrow we actually start to do the game. That's nice. I need to do one thing. Touch fish data license md. Free of any copyrights. Sorry about that, but my artists didn't release their work for public use. Sorry, I tried, but I did all the code, and all the code will be open source, but some of the assets were not done by me, so sorry. So, and obviously the shaders, we will use the file system to automatically try to load from Fish, and if it's not there, just falls through to dummy data. Actually, that sounds like a nice warm-up for tomorrow. So add file system layered that allows fallbacks for loading, right? So, and probably the shaders, they're dummy anyway, so we'll clean them up. We use image for image loading, so add image for texture loading. Yep, updated the to-do. Use multiple textures for testing. That's this one here. So all we did, we register them. This is reduce the middle mouse saying we use them, and from a user point of view, you say, hey, I want to use this texture, just do what you need to do. So that's easy peasy. We refactor material manager into generic manager, and that probably needs extracting at some point. And then we add texture support to renderer, add texture support to renderer. So everything's uppercase is basically a struct or a class. So it might look weird for an English reader, but it helps to actually find what is classes or structs. Switch the active material, use the texture. This is the manager stuff. So render effect, better. Wait. The render effect, yeah, exposes a program. The material has texture support and sort key. Add texture support to material. Calculate key for material. Actually, this is not so much of a head at uniform support to material. Program allow oh yeah, improve shader linking debug info. Remember, expose uniform locations from program. Wow, we did a lot. We should have done intermediate. So we added the license, we added some test data, and we actually added the texture support. So let's commit this, let's rebase this, let's push this. As always, and I need to close some tabs here, as always, everything is open source. Well, the source code, sorry about that, not the data. But at least you have something to play around with. And yeah, I'm gonna let this run overnight. Come on. If it compiles, and we can draw some stuff here. Isn't that nice? I mean, just chunk loads of data, and I'm not even sure what I'm drawing. So if I draw any symbol that has any meaning, I just randomly drew a pattern. Probably it's a propeller of a plane, right? So, me likey. So, no, let's move this here, because I want to be in the center of it while I do a quick check of who's online on Twitch. Everybody's offline. What is Jessica doing? Shall we? Well, you're gone anyway, so thanks for being here. Tomorrow, finally, we'll get into some gameplay.